Have you ever been in a sandstorm? Well, I have. I was drowning in sand and the day was dark as night. Recently, we're not only experiencing this kind of extreme weather event, but also rising temperatures and worsening air quality. The major culprit? Well, it's the burning of fossil fuels. Today, even though we talk so much about developing clean energy, still 80% of the world's energy comes from fossil fuels. As an electrical engineer, my solution is to include more renewables into the power grid, specifically the microgrid, a small-scale power grid that consists of local generators and local loads. Compared to traditional power grids that transmit large amounts of power from some big power stations to a wide area of loads, microgrids are more flexible and economical because they use local power generation to meet the local demand. You may ask, why don't we just replace all the fossil fuel generators in microgrids with renewable ones? Well, a major challenge is that the power generated from the renewables is highly dependent on the weather and time of the day. The fluctuating renewables will cause a huge mismatch between the power generated and the power consumed, making microgrids unstable. You may say batteries can compensate for this power mismatch, but they're still too expensive. So instead of using batteries, I designed a controller to balance this volatile renewable generation by manipulating the low voltage. The idea goes like this. Now, if the renewable generation drops, this controller senses it and lowers the voltage. Now, a key technical fact is that lowering the voltage would decrease the load consumption. So this controller optimizes the voltage to a specific value to ensure the power stays balanced and the loads are safe. To achieve better reliability, not only do I apply this controller within a microgrid, I also coordinate the controllers in multiple microgrids so that if microgrid A has excessive power, which means generation is larger than demand, then it can help microgrid B and C that have insufficient power. In a test system with 75% renewables, this controller showed over 70% improvement in balancing the power mismatch, compared with the existing controller in traditional power grids. This controller can be easily applied to all kinds of microgrids, such as smart buildings, local communities, or remote islands. And it is a step further to achieve my ambition, to build a greener energy future. Thanks.